Next example for LR parsing with the help of LR parsing table and with the help of grammar, how we can reach up to this string. So first make a tree from the grammar as we have done in the last example also. Start from S. These are the three production of this grammar: first production, second production and third production. So S tends to AA. Then what is required? Then the next is A, and further we need AA. So one A will get, so again we will break it in the same AA. Then what is required? B. So, and A tends to B also, so we will write B, and here also we will write B. So in that way, the first one will get 1B, then this is the second one, or AA, and this is the third one production, or we can say with the rule we get this, and this is the fourth one, and this is AA, this is the fifth one. So like that we'll get that string. So we can write here, first is A tends to B, and the second is A tends to AA, and the third is A tends to AA also, and the fourth is A tends to B, and the fifth one is S tends to AA. So now we'll see how we can get that string with the help of this grammar and this table. So first let's start with this help of stack, and as we know what is required, first A is required, and from 0 state to S3 string A production is there. So we can simply say like this: S0 to S3, or we can write here S0 to S3 A is there, and further we require A, so we can say the make of loop, and after that we require B, so we can say S4. From S2 through S4 what we have? B. So we can take B. So now start with the help of stack how we can get this. Start with 0 state with A transition. Where we are reaching at S3, we can say, so we can write 3 here. Now again 3 is required, so we are on the same state S3 only, so we will write A and third state, and after that what is required? Required B. After that AA, what is required? B. So for B, where we are reaching at S4, so write 4 here. Fine. So after that what is required? The reduction is required because A tends to B, so A, we will get A. So from here, the first we are doing just production, how it is going on, and from the rule we can simply say what rules we have. We have action like from state to transition, from which state we are going. So from 0 for A production we went to S3, and from A to B we can say S3 for B production, where we went S4, like here we did. So these are the first rule, and the second rule is reduction. Reduction we can say S comma A RJ rule is there when alpha tends to beta, like A tends to B. So this state is doing reduction here, so we will write the reduction. So how it goes: AA will remain same, and this A3 also remain same, but what we are doing, we are doing reduction for A tends to B. So instead of that, what will come here? A will come here. A will come here. So we can simply see from the table from third state for A, where we are reaching at 6th. So we will write here 6. Fine. From the table from third state for A, where we are reaching at 6th. So we will write here 6. After that, again we are doing, so we can say the reduction process here from state, here it is doing reduction. Alpha tends to beta for A tends to B. Here we are doing reduction. So now again we are doing reduction. What is for A, for the second rule, A. So here for A. So here 2 symbols dropped. So as we know from the rules, 2 symbols dropped. Now 4 symbols will dropped. So where we will reach? Where we will reach? Let's see. It will remain same. So this will A tends to AA. So we'll write here A. So again we will reach on the from third state A condition, where we will reach at 6. So we'll write here 6 again. Now again the same reduction. A tends to AA, A tends to AA. So again we will write here for whole, we will write here A. We will write here A. Now from 0 state for A, from the table we can say from 0 state if we reach A, so where we are reaching at 2nd. So we will write here 2. We will write here 2. So till now what we get? We get AAB. So now what is required? One more B is required, because what is the string? AABB. So for next B, from the second state for B, where we are reaching at S4. So we'll write here B4. From second state, from 0 state, here for B we are reaching at S4. So we can see from here. So we will write again we are doing the reduction for this A tends to B, because here A tends to B. So we will write here again 0, A, 2 and A. So from the second state, as we know, we are reaching at S4 for B. From the second state, here from the second state till here, after reaching A, from 0 state after reaching A, where we are reaching at 2nd, and again we need B, because AAB is over, but 1B is left for the string. So from the second state for B, S4. So we'll write here 4, and A tends to B, reduction we know. So for that we did 1. So from A, from second state A, where we are reaching at 5. From second state A, where we are reaching at 5. So we will write here 5. You write here 5. Now the last production S tends to AA. It is here. So we will write here whole. We will write here AA S. So from 0 state for S, where we are reaching at 1. Where we are reaching at 1. Here we are reaching at 1. And from 1 we know which is state is accepting state. So because this is accepting state, so we will write here $, because this is accepting state. It means it is $. It means our string get accepted with the help of this grammar and with the help of this LR parsing table. So these are the production which we have done, reduction through which we done all these things. So this is another example through which we can identify that our string get accepted by the grammar or with the help of table or not, and with the help of stack or not.